Welcome again to Math 800 Pre-Algebra. Today we are doing section 4.4, Adding and Subtracting Signed Fractions. Our objectives: 1. To add and subtract like fractions. 2. To find the lowest common denominator for unlike fractions. 3. To add and subtract unlike fractions. And 4. To add and subtract unlike fractions that contain variables. When fractions have the same denominator, we say that they have common denominators, which makes them like fractions. Here are two examples of like fractions. 3/4 and -7/4 have a common denominator. 6 over x and y over x also have a common denominator. These are like fractions, and these are like fractions. When fractions have different denominators, they are called unlike fractions. Here are examples of unlike fractions. 9 and 8 are different denominators, so they are unlike fractions. 3 and a are different denominators, so they are unlike fractions. When you're adding and subtracting like fractions, you can add or subtract only the numerators and the denominator stays put. So if you have a over b plus c over b, you simply add the numerators, a plus c, and leave the denominator alone. Same with subtraction. A over b minus c over b, you just subtract the numerators and leave the denominator alone. This is only true when you have common denominators. B's on the bottom, or any number, but it has to be the same. Recall that the denominator in a fraction tells you what size piece the whole is divided into. For example, say you were at a party with two pizzas, and one was sliced into tiny pieces and another was sliced into giant pieces. You have small pieces and you have big pieces. If George had two of the giant slices and Marcus had one of each, they both had two slices, but is it true that they have the same amount of pizza? No. These two you can combine together and say he had 2/6 of the big pizza. However, here, this slice is definitely a different size than this slice. This is 1/6, this is 1/18. We cannot begin to combine this size slice with this size slice to say that he had two slices of pizza. The size of the slice matters. In order to combine fractions to add them, they need to be the same size pieces, which means having the same denominator. We will now do some examples with denominators that are the same. Find the sum of 1/8 plus 3/8. 1/8 plus 3/8. You keep the common denominator and you just add the numerators, 1 plus 3, and you get 4. Technically at this point we have added the fractions. Our next step, however, is to simplify. Recall that all fraction answers must be in lowest terms. We will again be simplifying by using prime factorization. This is the preferred method for many reasons, but particularly because when you get into your next math class, you will be doing things with complicated fractions that involve not only numbers and letters, but addition and minus signs as well. And in order to simplify them, you must use this method, this prime factorization. So it is a very good idea to practice it now. We write them in prime factors, cancel out the common factors, and we're left with 1/2. We could look at this visually. Here is 1/8 plus 3/8. When we combine them, because they are the same size pieces, we can put them all together and we clearly have 4/8, and looking at this, it's fairly obvious that it's half the pizza. Recall that you're only adding the numerators. The denominators do not change. That's the biggest difference between multiplication and addition of fractions. When you multiply fractions, you multiply the top and the bottom. When you add fractions, you only add the top. You do not touch the bottom. You need to keep that straight. It's very confusing for many students, and a lot of students struggle with that. But when you are multiplying, you do top with top and bottom with bottom. When you are adding, you only combine the tops, you leave the bottoms alone. Recall that the denominator tells you the size of the piece. If you have a pizza cut into 8 equal sized slices and you eat one slice, and then come back and have another 3 slices, you ate a total of 4 slices, or 4/8 of the pizza. Just because you added to your pizzas didn't mean the slices got smaller. So the denominator can't change because that would be changing the size of the piece. And because you are combining them doesn't mean they got smaller or they shrink. You're just adding on to what you already had. So the denominator does not change. Another example. Find the difference 3/10 minus 7/10. They have a common denominator, so you just keep that and you just subtract the two numerators, 3 minus 7. 3 minus 7 is -4. Again, if you need to, you can rewrite it as adding the opposite. I don't care which method you use as long as you get to negative 4 over 10. You can write the negative either in the numerator or in front of the fraction. These two things mean the same. However, we do need to simplify our final answer. Negative 4/10, 4 can be rewritten as 2 over 2, 10 can be rewritten as 2 times 5, the 2's cancel out, and you're left with negative 2/5. Make sure to keep that negative in the answer. A lot of times the negative will be here, and then it just slowly disappears on you, so be very careful with negative signs. And again, this, though correct, is not done. It's like being halfway done with the problem and you didn't finish it. So even though this is not a wrong answer, it's not the simplified answer, so it's not the one we are looking for. Find the difference. 5 over x squared minus 2 over x squared. Even though they're letters, they're still the same. So the denominator stays the same, and we just do numerator minus numerator, and we get 3 over x squared. This cannot be simplified, so we're done with 3 over x squared. In order to add or subtract fractions with unlike denominators, you're going to have to find a common denominator. There are two methods for finding a common denominator. One is by inspection, and one is through a process using prime factorization. Some are easier to do by inspection. For example, if you are working with the fractions 1/2 and 1/3, it is pretty clear that 6 would be a common denominator because 2 goes into 6 and 3 goes into 6, and it's the smallest number they can both go into. In general, if your denominators are both prime, 2 is prime and 3 is prime, simply multiply them together to get your common denominator. No matter what, you can always multiply your denominators together to get a common denominator, but it isn't necessarily going to be the smallest one or the least common denominator. We'll talk about that more in a second. So, notice again, 12 is another common denominator because both 2 and 3 go into 12, but it is not the least common denominator. The least common denominator is the smallest number that both the denominators can go into. We shorten this and call it LCD. Find the LCD for 2/3 and 1/9 by inspection. Sometimes it can be easy to see that one of the denominators can go into the other denominator. To see if that happens, start with the larger denominator and decide, is that denominator divisible by the other one? Is 9 divisible by 3? If the answer is yes, then 9 is the LCD for both fractions. So, some of the easy ones to find. If you have two prime numbers, like 1/2 and 1/3, both denominators are prime, simply multiply them together to find your lowest common denominator. If one of the denominators is a factor of the other denominator, then the larger number just is your common denominator. However, what do we do in cases like this, where our denominators are 12 and 18? 18 and 12, neither one goes into each other, and they're bigger numbers, and so I'm not sure I want to sit here and try trial and error. That would take a while. So instead, we're going to use prime factorization. Our goal is to find a list of factors that covers both 12 and 18 without any duplicates. So start with the prime factorization for both. 12 is 2 times 2 times 3. 18 is 2 times 3 times 3. Pick either one to start with as your base for your LCD. I'm going to start with the factors of 12. 2 times 2 times 3. Then look at the factors of 18. Are any of the factors of 18 already included? Yes, the 2 is included, and one of the 3's is included. All we're missing is the second 3. Add that, and now you have included the factors of 12 and the factors of 18, and you have no duplicates. Our lowest common denominator is 36. Had we just multiplied 12 times 18, we would have had a much bigger denominator than we needed, and that can make the problem very difficult to do for your arithmetic. It's very important that you find the lowest common denominator to keep the arithmetic doable. That is another caution to not repeat the factors. We want the smallest common denominator because that will make your arithmetic easier to do. What is the LCD for 11/15 and 9/70? Same thing. We don't want to just multiply 15 and 70. That would give us too big of a number and make your arithmetic very unwieldy. So start with the prime factors of both of them and then find a combination that covers both without any duplication. 15 is 3 times 5. 70 is 2 times 5 times 7. Start with either one of these. I will choose to start with the factors of 15, which are 3 and 5. Then look at the factors of 70. Are any of these factors already included? Yes, the factor of 5 is already included, so what I need to add are the 2 and the 7. This is my lowest common denominator. When I multiply this together, I get 210. That is still a large number. Think about how much bigger this would have been had we included an extra factor of 5.